Hi there, friends and neighbors. I'm going to show you how to do a complete example of a results section for a paired t-test. This is what you get if you've got a quantitative variable and you measure the same group of people twice, and you want to see if there's a change from time point 1 to time point 2. Use a paired t-test for that. These are the elements that go into your typical results section, and in fact these are the elements that are required for my intro stats results section. I need to see descriptive statistics, a graph, and inferential statistics. The inferentials consist of the HO, H1, and alpha, the assumption check, then your fun stuff, the confidence interval, test statistic, degrees of freedom, p-value, decision about HO, and interpretation of the confidence interval, and then finally interpretation into plain English. Remember that this is about making real-world decisions. All right, so I've got the data set already loaded into EZR. They're called laser cannon pew pew. And what they wanted to know is if people using the HoloLens to do a simple web-based search task, just a simple search engine task, we're going to be faster or slower than people using traditional keyboard interface. So let's go ahead and get started. The descriptive statistics are we're going to need the means and standard deviations of the two variables. Let's go ahead and get that. Statistical analysis, continuous variables, because again it's quantitative. Numerical summaries is how you get your numerical summaries, as the name implies. Desktop time and holo time, that's what they recorded, was how long it takes people to do each task. Then I'm going to click OK, and there it is. Get your sample means, your sample standard deviation, sample size, and the 5-number summary. So I'm going to copy that. Looks like we have 10 of each for a total of, well, it's 10 people. Okay. Right click, paste. Now I'm going to select that and change the font to be Courier New so that it is monospace and it actually looks good. There are your descriptive statistics. But what we're really interested in is the difference from time 1 to time 2. That is from desktop to holo. Okay, and that's what we're going to test our hypothesis about. The null hypothesis, HO, is that there's no change over time. That is, the mean of the difference is equal to 0. It does not change from one task to the next, that they're the same amount of time. The alternative is that mu of d is not equal to 0. There is an effect. Alpha can be anything you want. The conventional one to use is 0.05. And we'll get a graph, and we'll get this other stuff going in just a bit here. The assumption check, we need, of course, we always assume independence. That is, each person is independent of each other person. That's achieved with simple random sampling. And then we're assuming that there are either at least 30 pairs, which there are not, there are only 10 pairs, or the difference scores are normally distributed, which they're probably not. Seems very unlikely, but let's find out. I'm going to actually make a graph of that. Graphs and... oh wait, I don't get the difference scores, do I? I haven't got the difference scores computed, so I can't think of an easy way right now to check that assumption. What we would do is compute the difference scores and make a histogram or box plot of that. I'm going to skip that for now. Let's go right to the analysis. Statistical analysis, continuous variables, paired t-test. Oh, and I'm just going to note n equals 10, so we do not meet the assumption. We really should compute difference scores and make a histogram to see if it is normal, if it is approximately normal. I'm not going to bother with that right now. Okay, so first variable will have desktop minus holo graph. So if we get a negative average, that means the holo is taking longer. If we get a positive difference, then the desktop takes longer. I'm going to make it a two-sided test, 95% confidence interval. Click OK. Okay, now I'm going to scroll up till we get to the mean of the differences. The average difference is negative 223.4. That sounds pretty big. Here's our t with 9 degrees of freedom and our p-value. I'm going to paste that here. Paste. Okay. Done. Now I'm going to get the confidence interval. Here it is, the 95% confidence interval. And there it is. Okay. Now, I need to make a decision. P-value. Oh, we didn't get our graph. Let's make a graph. I think I might just make a graph of, you know what might work? A scatter plot might be fun. That might be fun. Or I could do a line graph of the means or repeated measures. I'm do a line graph of means for repeated measures. That might be a fun way to do this. Let's choose that. Desktop against hollow. And then show different groups in separate graphs. That might be cool. Let's see if that works. Okay, doesn't work. Let's turn that off, rerun it. Oh, I did that wrong. There's no grouping variable. Okay, so select both of those. Then click OK, and there we go. All right. Well, that ain't that interesting, but we would copy this graph and paste it into our Word document. You can right-click to copy it, and I'm just going to move along a little bit. Scatter plot would also be an interesting graph. Let's make one of those. Graphs and tables, scatter plot, and then choose desktop and hollow. Click OK. There's another interesting graph that would be appropriate for this because we can see the two variables plotted against each other. And you just copy this and paste it into your Word document. Anyways, let's make our decision. We do not meet the assumptions, so really we shouldn't be doing this, but it's a class project and we want to see how it's done. So make my decision. The p-value is less than alpha, or I should say less than or equal to alpha. So we reject HO. We are 95% confident that the difference in time is between 392 minutes longer for hollow and 55. Is it minutes or seconds? I think it's seconds. 55 seconds longer. The point is, the HoloLens. Point is, the HoloLens, of course, takes longer to do this task. That's what we conclude. Well, there is sufficient evidence to support the claim that the HoloLens takes longer for the task compared to the desktop. Okay. Slightly incomplete graph. You get a more complete graph if you run this. Oh, I just thought of this good way to get a graph. Statistical analysis, continuous variables, repeated measures, ANOVA. Just run it that way. You get the same answer, and you get a cool graph out of it. So I'll run this, and there's a cool graph. So what I'm going to do now is copy that graph. Again, if you've got a Windows or Mac, you can just right-click and copy it. I'm using Linux. It's a little bit different how I'm setting it up. So I'm going to do it differently. Tools, selection, select a rectangle. I'm going to cut these out. Go back to my Word document or my word processor and paste it. Anchor it as character. Make it smaller. Cut it. And there we go. So that's a complete results section from beginning to end. Didn't quite check the assumptions carefully enough, but I could tell that we were just going to fail anyway. All right, that's it.